This is a video on solving inequalities. Now you can see that I have this equation here. It has variables on both sides, and I know it's an equation because it has an equal sign. Here I have almost the exact same thing, right? There's a 5x in both, there's a minus 3 in both, there's a 2x, and there's also a minus 9. The only difference is the symbol in between. This is the less than symbol. Sorry, less than or equal to. So if you know how to solve this equation, then you are almost ready to solve the inequality. So just like an equation, like I would subtract 2x from both sides. That would give me 3x minus 3 equals, those 2x's cancel, so I get 9. Minus 9, I almost forgot. So I could do the same exact thing here. I'm going to subtract 2x. I get 3x minus 3. I drop down the inequality, and I drop down the minus 9. The next piece that I'm going to take care of is this minus 3. I'm going to add 3 to both sides. I drop down my 3x. It's equal to negative 6. I'm going to do the same thing on this side. 3x is less than negative 6. And my last step in each type here is to divide by 3. And you might lose that negative there. I'm going to bring it a little closer. So we get x equals negative 2. On this one, we get x is less than or equal to negative 2. So just a subtle difference here is the inequality symbol. Okay? And a subtle difference is that this is the only solution, whereas x is less than or equal to negative 2 would include anything less than that. Negative 3, negative 4, these are all solutions. Negative 5, negative 100. Any number less than or equal to negative 2 is a solution. So that's one difference. There's also another significant difference, and that is there are times when you are required to change your less than symbol to a greater than symbol. And that is when you multiply or divide by a negative. So I'm just going to do a much easier problem, like a one-step inequality, just to demonstrate because they take a lot less time. So let's look at negative 2x is greater than 12. In order to solve for x here, I'm going to divide by a negative 2. If I divide by negative 2, I end up with x, and I get negative 6. But I just said if you multiply or divide by a negative, you had to flip the sign. So this becomes, instead of greater than, a less than. Now, the reason for this is fairly complicated, and I don't want to confuse anyone. So I'm just going to leave it at this. When you divide or multiply by a negative, you have to flip the sign, and there's a very complicated mathematical reasoning for that, and it's best just to understand that that's what you have to do. If you ever get to pre-calculus, I can explain why. The only other time that you would want to flip the sign is, well, actually there's two. So let's do another one of these. Let's do negative 2/3 a is less than or equal to 4. So in this particular one, I'm going to zoom in for us so that we can see it a little bit better. I need to cancel a negative 2/3, so I'm going to multiply by the reciprocal, which is negative 3/2, multiply by negative 3/2, and I multiplied by a negative. Not that this number is negative or not, okay? It's if you're multiplying by a number, and that number that you're multiplying by is negative, that's when you flip the sign. So right away, I'm going to flip that sign. I know all of this ought to cancel. That's the goal. And then when I multiply 4 by negative 3/2, I get negative 12 divided by 6. I'm sorry, divided by 2, which is negative 6. And I've already done the sign flip, which I like to do this little curly Q arrow just to symbolize that. Okay? The only other time is when you have a variable on the right and you want it on the left. So for example, if you went through a problem and you end up with something like this. 17 is less than b, but you want to write it on the left side, okay? So basically you're switching the two values there. What you're essentially doing, okay, the shortcut is just to jump right to it and say b is greater than 17, all right? That's the end result, and I'm okay with just accepting the shortcut and going. But if you really wanted to know what was happening here, you really could subtract 17 from both sides. You would get 0 on the left, and you'd get b minus 17 on the right. Then I could subtract b from both sides. That's not a 6, it's a b. So 0 minus b is negative b is less than negative 17. And for that particular problem, I would divide by negative 1, and I would get b. Because I'm dividing by a negative, I have to flip my inequality, and I'll get my positive 17. Shortcut, when you flip it, you flip it. And that's really the only major difference with inequalities. In a separate video, I'll show you